All right, let's start with the first question. The first question is, looking at the lab, what are the two types of electric charges? Okay, this is going to be super difficult. Anthony, we'll start with you because I know you can handle these hard questions. What are the two types of charges? Oh, excellent. Positive charges and negative charges. Positive charges, by the way, are protons. And negative charges are electrons. Now, it's worth mentioning that protons are not the only positive charges that exist in the universe, and electrons are not the only negative charges that exist in the universe. They are just the most common, and they're the ones used for electric charge and electricity. It's not to say that, again, that they're the only ones. They're not, but they are the ones that are used for this. So, when we try rubbing the balloon on the sweater, so the balloon and the sweater have opposite net charges. Do they seem to attract or repel? And what can you say about the types of charges that seem to attract or repel? So, Luke, what seems to happen here when we mess around with this?
It seems to attract.
Yeah, so if I rub the balloon on the sweater, now the balloon is negatively charged. The sweater is now positively charged, and they seem to attract one another. Okay, so what can we say? Well, we can say that, there we go. We can say that, so opposite charges attract. So the sweater picked up the negative charges, so the sweater has a negative net charge. And the, or sorry, I meant to write the balloon. That's my bad. The balloon has a negative net charge. The sweater has a net positive charge because it lost those charges. Now, here's an interesting question. What happens if I bring it near the wall? Now, if you've ever brought charged balloons near walls, you'll notice that they do this. Oh, nope, they don't do that. There we go. They stick to the wall. If you've ever noticed this before, well, I had some balloons, and my hair is particularly staticky today, so I can probably make this work if I can find my balloons. Oh man, I can't even find my balloons. That's too bad. I know. I'm just not on it today. Oh, what? Oh, nope, that's easy to get confused. That was hot glue. Does he have any balloons? He might. I have water balloons, but those aren't going to work for this. I know. So anyway, so this is something that's interesting to look at because notice that the wall is not charged, and rubbing the balloon doesn't take charge off the wall. But this is something called induction, which we'll come back to, which has to do with how we cause charges to happen. So we'll come back to this example when we get to induction, which is the third section that we'll look at. Okay. So we talked about that. So now we're going to reset it. We're going to do two balloons. We're going to rub them both on the sweater. And we're going to notice the effect that they have. So if I get my second balloon now, I'm going to rub that one on the sweater. So now the sweater is very positive. But the balloons are both negatively charged. And notice that the balloons repel each other. Okay? If I bring it over here, it'll stick to the sweater. Okay? Because the sweater is incredibly positively charged. But if I don't bring it close enough to the sweater, it'll repel each other. So do the things seem to attract? No. So like charges repel. So both balloons have negative net charge. Okay. All right, any questions so far on the first part? Yay! So, contact is where you're transferring charge directly from thing A to thing B. An example of this is rubbing the balloon on the sweater. So in that example that we did, okay, when we have the balloon, I'm rubbing the balloon on the sweater. That's picking up charge directly from there. Okay, that's transferring charge by contact. So I'm taking it directly off of the sweater and putting it onto the balloon. Notice that that doesn't have any effect on the yellow balloon because the yellow balloon has not been charged yet. So that's transferring charge by contact. That's direct transfer from A to B. Where did B get its charge from? It got it from A. So that's transfer of charge by contact. Okay? What about induction then? So, Hunter, what do you think induction is for transferring of contact? Yeah, so induction is where you transfer charge without actually transferring charge. Okay? So, thing A is charged because of thing B, but not from. Now, that probably seems super confusing, and it is, but you've actually seen an example of this already. Okay. What happens to the wall? Let's just do the one balloon here. Oh, okay, of course. What happens to the wall when I bring the charge near? Notice that it pushes the electrons in the wall out of the way. And what charge is the wall now? Positively charged. It got positively charged because of the balloon, but it is not charged from the balloon. In other words, there are no electric charges that left the balloon and went to the wall. However, it is charged because of the charges that were in the balloon. Okay? Another good example of this is lightning. Now, you're probably saying, oh, you mean like how the lightning jumps from the cloud to the ground and they're not touching. Nope, not that. Not that. That happens because the balloon gets negatively charged. It builds up all these excess negative charges. What that does is it induces a charge of positive in the ground. Does the ground have just a ton of extra positive charges? No. But what happens is the cloud builds up a huge amount of electric charges. Why am I drawing for myself when you can't actually see it? I have no idea. Okay? This builds up a ton of electric charges. It pushes the ground's electric charges out of the way. And that means the ground is positively charged. When that becomes large enough, then the lightning will jump and the charge will jump to the ground. So this is actually conduction. But this is not. The ground becomes positively charged because of induction. The charge transfers from the cloud to the ground by conduction. When you get shocked by a doorknob, that is conduction. But the reason why the shock happens is because your finger coming near makes the door positively charged. It's not normally positively charged, but getting your finger close makes it positively charged, and then the charge jumps the gap. So that's the idea. So the balloon in the wall, the balloon makes the wall positively charged, and then when you pull the balloon away, it goes back to neutral. It doesn't actually transfer charge. But induction is a very complicated one. Okay? Anyone have any questions on induction? So what's going on with this one is that he's basically building charge on his body. So builds charge. When it's large enough, it'll jump to the doorknob. Okay. So where is he getting the charge from? Okay. Well, the simulation does a good job of showing this. He gets it from rubbing his foot on the carpet. And the strength of the charge is going to be negative. Okay. The reason why it's negative is important. So he gets it from the carpet. And it's negatively charged. The reason why it's negative is because positive charges generally can't move because they're stuck in the nucleus, unless they're hydrogen atoms, which are a nucleus, in which case then they can move because the whole nucleus moves. Okay, but that's not very common. That's just used in particle physics-y stuff. So generally, it's just electric charges that move. Okay. So the transfer of charge from the carpet to his foot and then from the hands to the doorknob, all that kind of stuff. What kind of transfer do we think this is? Nathan Wood, what do you think? Is this conduction? Is it induction? What do you think's going on?
Induction.
All right, why so?
Because it's not making physical contact with the doorknob.
Okay, so there's a couple of things going on here. So first of all, it is conduction between his foot and the carpet. So the foot and the carpet is conduction. He rubs his foot directly on the carpet, and so that's conduction. All right, so he builds up a charge, And this is why I wanted to bring this on with the induction idea. So what is happening between his finger and the doorknob? Well, what's happening between the finger and the doorknob is that the increased charge on the finger is actually going to do conduction and induction. So, first of all, it's going to do induction. So it induces a positive charge on the doorknob, which you can't see. So by charging his body, it makes the doorknob positively charged, in opposite of his. However, the actual shock is conduction. So the thing you want to be careful of is thinking that induction doesn't need to be touching. That's not what it is. Induction means that it charges without charge transferring. When I touch the doorknob, charge is transferring. So that is conduction. Even though it's not contact, it is conduction. And that's why contact is not my favorite word for phrasing it, but that is what the book uses. It's conduction. It allows his charge to transfer over, again, it can be over a distance, but it doesn't have to be. Okay? Questions on that one? All right. Let's get at least one more done here.